Welcome to this video from Derby Physics Tuition, and in this video we're going to look at a mechanics problem, and this is our problem here. So it's a statics problem of a ladder resting against a wall, and statics is the branch of mechanics concerned with bodies at rest and in equilibrium. So here you can see in the diagram at the bottom right that we've got a ladder resting against a wall at an angle of 60 degrees, and the ladder is on rough ground and leaning against a smooth wall. And part A says draw the resultant force of the wall on the ladder. Now, under normal circumstances, the ladder, if it slid down the wall, would slide, the top of the ladder would slide down like that, and so we would have a friction force acting in the opposite direction. Okay, and the other force that we would have is the normal contact force, so the contact of the wall against the ladder, and that would act in that direction, so we'll call that N. Now basically the question says that the ladder is leaning against a smooth wall, so we're going to assume that there is no friction force, so let's get rid of that one. Okay, and so what that means is that our resultant force in this situation is just the normal contact force. There is no force due to friction because it is a smooth wall. So that's the answer to part A. And part B, draw the resultant force from the ground acting on the ladder. And it says the ladder is on rough ground, so that means there will be a friction force. Now if the ladder slips, the bottom of the ladder will move to the left, so our friction force must be acting to the right. Okay, and we'll label that F. Again, we've got our normal contact force between the ground and the ladder, and we'll call that N. So draw the resultant force, so part B, draw the resultant force from the ground acting on the ladder. So it's just a resultant of these two forces, the normal contact force N and the frictional force F. So we'll just sketch that, okay, and change colour just to make it a little bit clearer. So our normal contact force would, our reaction force would be acting in that direction. So parts A and B are testing your understanding and knowledge of the forces acting on a ladder when it's resting against the wall. And part C, the ladder is 6 meters long and has a weight of 300 newtons. Use this information to calculate the resultant force of the wall on the ladder. So what do we know here? The ladder is 6 meters long and has a weight of 300 newtons. So the weight acts at the center of gravity of the ladder, and so we can draw it in that position there. Okay, and then we've got the resultant force of acting on the ladder at the top of the wall, which we drew in for part A. So it's still a smooth wall, so there is no friction. So it says calculate, and we're trying to calculate that force R. So the way that we can do this is by taking moments from this point here. Okay, we'll call that point A. So for part C, take moments from A. Okay, and if we take moments from A, we don't need to worry about the forces acting at that point. So all we're concerned with is the moment due to the weight of the ladder and the moment due to the resultant force of the wall acting on the ladder, acting at the top of the ladder. So the principles of moment states that for an object to be in equilibrium, or a system to be in equilibrium, the sum of the clockwise moments equals the sum of the anti-clockwise moments. Okay, so we've got the weight of the ladder, which is trying to turn the system in a clockwise direction, and so moment is force times perpendicular distance from the pivot. So the ladder is 6 meters long, so this distance here is 3 meters. Okay, so but we need the component of the force acting perpendicular to the ladder. So when you take moments, you need to use the component of the force acting perpendicular to the ladder. Now, using simple geometry, this angle here will be 60 degrees. So the component of force that we need is 300 cosine 60. Okay, and the distance from point A is 3 meters. And that is balanced by the anti-clockwise moment, which is the reaction force at the top of the ladder. Okay, and draw a line there. So we need to calculate the moment due to the reaction force at the top of the ladder, and that will be equal to the force times the perpendicular distance from the pivot, which is point A. Now we need to work out the component of the force perpendicular to the ladder. So this is a Z angle here, so this angle here is 60 degrees, and this angle here will then be 30 degrees. Okay, so the component of the reaction force is R cosine 30. We need the component of the force perpendicular to the ladder when we're calculating its moment, and the distance from the pivot is 6 meters. Okay, so they are our two moments. We've got our clockwise moment and we've got our anti-clockwise moment. Okay, if you calculate this side, 300 cosine 60 is 0.5, so that side is equal to 600, and the right hand side will be equal to 5.20 R. So the reaction force is 600 divided by 5.20, and that is equal to 115 newtons. So the important thing to remember here is that the ladder is in equilibrium, and just a reminder that when a ladder or a system is in equilibrium, that means that the forces are all balanced. So there are two main points there. There is no resultant force and there is no resultant moment. There's no resultant torque. So hopefully you found that video useful, and if you do have any comments or any questions, do leave them in the comment section below, and thank you very much.